I know this looks a little weird, but it's just a few different operations applied one after the other. This might be comparable to if it said x minus 3 square root of that, and then cube root of that, like cube root of square root of something, right? It's x minus 3, the log base 3 of that, and then the log base 2 of that. So you can just start to work your way towards solving it, right? If the outermost function here, right, you have kind of an inside function, the next one out, and then the outside one. Just look at that as, don't even look at what that is at first, right? Just think of it as, it says log base 2 of something, right? Log base 2 of something. To get rid of that log base 2, what can I do? I could do anti-log base 2, right? Because that's going to cancel that out. And then whatever the something is in yellow there, log base 3 of x minus 3 equals 2 to the power of 1. The inverse of a logarithm in whatever base is just anti-log in that base. And then again, you can do that. Now it's log base 3 of something, right? Don't worry about what the something is. Log base 3 of something, anti-log base 3. That's going to cancel that out. So you have 9, and you have x minus 3. And then, of course, if x minus 3 is 9, x is 12. Now, you may or may not have other base logarithms on your calculator. I know I've been telling you you don't have them. On certain calculators, you do. I think if you have an 84 and you've updated it to the latest whatever operating system, I think there is different log base button on there somewhere under one of these menus here. Log base, I think, 2 of, well, we'll get really crazy here and put it all in at once. Log base 3 of 12 minus 3. So I'm just putting the number in, right? I'm just substituting in I'm checking my answer. It gives you 1. It should give you 1. Now, even if you don't have those buttons, later on you'll find a way of doing it. But if you do have those buttons, you can always check your answer on these things. That being said, I do expect you to know how to solve some of these without a calculator, right? What are the restrictions on the variable in this case, just while we're thinking about it? There's the expression that has the variable in it, and it says log of that. What are the restrictions? You might just be able to see x has to be greater than or equal to 3, right? If you're not sure, you can say whatever's inside the brackets where you're taking the logarithm, that has to be greater than 0. Whatever it is, like if somebody gave you something that said log of 2 minus x over 5, negative 5, you can just write that 2 minus x over negative 5, that has to be greater than 0, and then solve that inequality to figure out what the restriction is if you can't see it just by looking at it. You can always just say this has to be greater than 0 and then solve it, right? So this works with our restriction, right? This is okay. The next question you're going to notice that, well, if you look ahead to the answer here, you might predict what's going to happen when we do this. After you solve this, you're going to have to do some thinking here, right? And you can think about these two questions. Can I just right away get rid of all these logarithms? Can I just say, well, why don't I just cross them all out? Can I do that? Can't do that, right? You can't do them individually. You can only do the entire side. You need to put this together first. You have two logarithms added together, right? You have this logarithm and this logarithm. You got to put them together as one thing first. And you know when you're adding two logarithms, how you put them together. Then you can think about what you do with the things you're taking the logarithm of. So can you try that right now? See if you can get to a point where you can put together a solution. See what you get. Think about why one of them is rejected at the end here. if you've thought about that first one, or that number 3, and you wanted to check or think about it, 2 logarithms added, you can multiply those two things, right? Multiply those two expressions and do it as a single logarithm. You could write it out as what those two things are multiplied. X times x minus 2 is x squared minus 2x. Right? And probably you're just going to jump out to that. I'm writing everything here just so make sure we can follow along. And then to get rid of the logarithms, now that you have a single expression on each side, you can use your anti-logarithm base 2 to cancel that out. It happens that there's a logarithm on both sides, so both of them cancel out, and you just have a 3, and you have x squared minus 2x. Now you've reduced it down to a quadratic, something that you worked with in grade 10 and 11. You can solve that by trying to factor it. To factor, you got to put everything on one side, make 0 the other side. If you try to factor it, the rule of Math 12 seems to be that you're always asked ones that factor, but if we just made up random ones, they probably wouldn't factor, and then you'd have to resort to using what? What would you have to resort to if it didn't factor? Quadratic formula, quadratic equation. You'd have to either, whether you have it on your calculator just to be able to spit out the answer or not, doing it the long way. It's up to you. Oh, look at that. I'm not doing well on... Oh, no, that's right. That's right. I thought I messed it up for a second. Now, it looks like you have 2 answers here. The thing is, we got to think about the restrictions, okay? You have to think about what the restrictions are on this original equation. What are the restrictions? You have 2 expressions here. You have x and you have x minus 2 that you're taking the logarithm of. So x minus 2 has to be greater than 0, and x has to be greater than 0. What do each of those say? Like this one says x is greater than 2, right? And this one says x is greater than 0. If you have 2 restrictions here, one of them might make the other one redundant, right? Which one of those is the one that we could just use? We only have to say one of them, right? Because one of them implies the other one. If it has to be greater than 0 and it has to be greater than 2, what has to be true? It has to be greater than 0, right? It's like if somebody said you have to be older than 14 and older than 16 to do whatever it is. I don't know. Which one of those matters then? Which one has to be? Did I just identify the right one, by the way? I'm listening to you guys. If it has to be greater than 0 and it has to be greater than 2, which one does it have? Which one overrides? Think about this. If somebody says, to be able to drive in this province, you have to be older than 14 and older than 16. I know it sounds goofy, but let's say there was two different things that were giving you licenses or something, right? One said you have to be 14, one said you have to be 16. And you need both of these things to be true. You got to be 16, right? Doesn't matter that you get the one, you have to be able to get both of them. Both of these have to be, it has to meet both of those restrictions, right? So really, it has to be greater than 2, because if it's greater than 2, it's greater than 0. Yeah, I mean, really, you could just say, well, the other one's implied in that if you're looking at the restriction. Think about which one applies. I guess it doesn't hurt if you say and it has to be greater than 0, but if you know it has to be greater than 2, it has to be greater than 0. The only reason that is because when you get these numbers, you need to look back and see. In reality, you don't necessarily have to write the restrictions. You just have to be able to check the restrictions. So you can take the numbers and just look and see if they work, right? If you took a 3 and said 3 minus 2, does that work? And 3, does that work? This is positive. 3 minus 2 is positive, so this one works. But if you put a negative 1 in there, it already doesn't work here, and it doesn't work there. It has to work in both of them, right? You can't take the logarithm of a negative number, so even if it fails one of them, like negative 1 fails on both of these, it's not greater than 0 and it's not greater than 2. It's got to work for both of them. So that gets rejected. You can cross it out. You can say reject, whatever you want to write. You got to show somehow that you're getting rid of that answer. There's only one solution here. If you tried to check it on your calculator, it would say error when you tried to put in the -1. The reason that happens is sometimes the operations you do cause the two sides to be equal even though they weren't before. You've had that before with square root equations, with radical equations. If you have square root of, I don't know if I can think of one off the top of my head here, 3 minus x, we won't make it too complicated here, -3. If you square both sides of that, what do you get? You know what? Let's just do this. Here's two. This is why it happens. -3, +3. Are those things equal? They're obviously not, right? If I square both sides, if I can do an operation to both sides, that what happens as a result of that? 9, 9. Now they're equal, right? Sometimes the operations you do to both sides create things that are equal that weren't before. It's the same here. Sometimes the operations that you do create, like this multiplication, right? Using that multiplication there. Sometimes you might create something, either the multiplying the two brackets or doing this anti-logarithm, or somewhere along the way we've created an extra solution that isn't a solution to the original equation. All right? There's other things here, but the concept is no different. You're going to use the anti-logarithm, but you got to combine things together first. I might have made it tricky for you to check the restrictions like this one. The restrictions are, you got to think about what the restrictions are there and look at what gets rejected. Make sure you notice that. What else have I put here for you? I could have put one where, like everything I've put involves a plus. I probably should have put one that involves a minus, like log of x minus 2 equals 4 minus log of x plus 3. Really, you can change things around like you did before, right? You could move this to the other side and make it positive if that makes you feel better. You can work with equations just like we have already, moving things from side to side. So I think you're at the point where you can work on the rest of the questions without much more direct instruction from me. You're welcome to ask questions individually or ask each other. Notice that I put some extension questions in here. If you want to draw the line there and then work on the practice at the back of the thing, that's fine. If you're aiming to get 90% plus in the course, you should have a look at some of these. Well, I don't want to do them right now because you can't approach higher level questions as learning how to do these. I can show you a solution at some point, but it's going to be something you have to try and play around with first. It isn't like these things are pretty. I mean, if I say here's how you do these, you could go home and you can try working on them. But higher level thinking questions, you're never going to see one that looks like this again. So it isn't that we need to learn the steps to do this type of question, because you're not going to see one like that again. You are going to see other H-level questions. I'll give you some solutions at some point for those, but I want you to try playing around with them first. There's some pretty difficult ones there. But let's work on let's make sure we're okay with the first things first, okay?